What the freak is going on, everybody? It's me, CJ. Today, we're going to be talking about Unit 8 in AP Calculus AB, and we're just going to go over like a little brief thing, like the first things you got to know about it, so you can be ready for like maybe your first quiz, or I don't know, maybe you just want to start learning early. But this is the Unit 8 tutorial. The first thing you learn in Unit 8 is something called average value. Now, what's average value? So let's say you got a function just like this. Average value, it's basically the point on this function, which is equal to the average y value of the curve. So for this curve, it would look something like that. So basically, if you were to fill in, maybe we should use two colors for this, but if you were to fill in this curve, the area to the x-axis, it would be equal to the average y value's area to the y-axis. So it's basically just turning it into a rectangle. And I'm gonna go see if I have another color over here so I can show this a little better. While you're at it, maybe you can go follow me on Instagram at CJ Cariaso for some awesome BMX clips right here. So this rectangle equal to the area to the x-axis of the curve. That's basically it. So do we need to write that down? I think y'all got that. So on to the formula. Basically all you gotta do is when you see something like average rate or average value, just plug it into the formula, and that's literally the whole thing. It's super easy. So let's try out an example. So example, fish are leaving a lake at a rate of f of x equals 4 plus 2 to the power of 0.1 times t squared, or yeah, t squared. Let me write that a little clearer. From the interval 0 to 5, t equals hours and f of t equals fish per hour. Find the average rate fish leave the lake. So all we gotta do, so it looks like we're going from 0 to 5. So our bounds are going to be 0 to 5. So A and B. So 1 over 5 minus 0. Then we got f of t. Oh, wait. Hello? Alright, there we go. So, where was I? We're not putting f of x. We're going to put in the actual function. So 4 plus 2 to the power of 0.1 t squared. And then you can't forget your dt. So the two most commonly forgotten parts are this little 1 over b minus a at the front, as well as the dt, dx, dy, whatever it is at the end. And once you got that in, you can just plug that into your calculator, and you should be getting 6.054, which is the average rate of fish per hour that leave the lake. Now, instead of fish per hour, this can be a lot of things. It could be average velocity, average, I don't know, just average anything. And a common one is usually velocity, that's why I say it. So be ready if that pops up on a test. So let's say this was velocity. The average velocity would be 6.054 meters per second, miles per hour, whatever. And so yeah. And there's one thing that you can do, like maybe you want to find the exact value where the point is the average value of the curve. So what you would do in that case, you would just set your function equal to the average value. So 6.054 is equal to 4 plus 2 over 0.1 times t squared, and then you just solve for t. I'm not going to do it because that looks like it's going to take forever, and then it looks hard, and I don't like doing hard things. Just kidding. You have to do hard things in life if you want to succeed. But I'm just not going to do it for this one. So, next concept. That concept's super easy. Should be a free 4 on your test. So we got the area between two curves vertically. Now this gets a little confusing. So, an example here. Let's say I said I wanted you to find the shaded area of these two little things right here. And they're basically a triangle, but one side is like curved. Like there's no equation that you can use to find that. Like, so how are you gonna find it? It's impossible. No, it's not. Let me show you how. What if you do 2 times 4? That's wrong, because that is a rectangle. But what if you subtract out this area, which is a semicircle that I drew really poorly? So minus 1/2 times pi 2 squared, and now that's your exact area of the thing. Now this is the same concept that you're going to be using in this, or that's kind of just how I like to think about it. But it can get a little confused. It can not work sometimes if you think about it like that, especially when it goes into the negatives. For example, we got this one right here. So we got x equals 2x over pi and y equals sine x. We're going to find the area of the shaded regions. So we're going to find, so we can do this part really easy up here. So all we got to do is 0 to pi halves of sine x dx, and what's subtracted out of the sine x is the average value, or the integral, or the area to the x-axis of x equals or y equals 2x over pi. I don't know why it says x equals that. So we can say minus 0 to pi over 2 of 2x over pi dx. Now, once you subtract that out, that should give you that little skinny region right there. But we still got to find this area, which gets a little confusing. So a better way to think about it is just top curve minus bottom curve. So in this case, the top curve was sine x, which worked out just like this. But in this case, the top curve is moving back to y equals 2x over pi. So we're basically going to do the same thing, but we're going to change it up now. So I'm going to put this side over here. We got negative pi over 2 to 0 of 2x over pi dx minus 0 to negative pi over 2 sine x dx, and that should give us what this little area is. And then all we gotta do is add those sides together. I'll just add some parentheses just in case. And there you go. Now you have the average value. You just have to plug that into your calculator. Not 100% sure what it is. I don't feel like entering it in right now. But if you enter that in, that should give you the right answer. And so yeah, let me make sure, double check all this stuff. I don't want to make any mistakes. And a lot of teachers will teach you to put them into all into one function. But for me personally, I've liked it better, or I kind of like remember it better if I split it up into 2 functions. So yeah, that's my method. If you use this method on your test, maybe like comment on the side of the test, be like, "Thank you, CJ. This is the CJ method," or something. I don't know this. But yeah, now let's add in a couple more lines. So we got vertical number 2. We got y equals negative x plus 4, y equals x, and y equals negative 3x plus 4. And I graphed it out nice and big over here so we can get a little diagram. So it looks like what we have here is a triangle, of course. And this top line, which I believe is, I should probably label these. So this is negative x plus 4, negative 3x plus 4. And this is y equals x. So those are our functions that give us these lines. So the top, it looks like we're finding the area of the curve, or area in relation to the x-axis of y equals negative x minus 4. And then it looks like we slice out the areas to the x-axis of negative 3x plus 4 and y equals x. And they're on a little bit different intervals, so I'm going to show you how to do that. So what we do, looks like we're going from 0 to 2. So we're going to plug that in for our bounds. We got 0 to 2 of x plus 4 dx. Now we got a minus. It looks like we're slicing out the negative 3x plus 4 from 0 to 1. So minus 0 to 1 of negative 3x plus 4. And then minus from 1 to 2, we got y equals x minus 1 to 2 of x. Can't forget your dx's, guys, otherwise it won't come out in the calculator. Then once you do all of that, then you should get the answer 2. Did you guys see that? I hope you did. Just in case you didn't, so we got this here, which is the top curve, minus the slice from 0 to 1 that's taken out, and then minus the slice from 1 to 2 that's taken out. So, yeah. And let me double check if this is right. I did this problem a while back. You guys can't look at my notes, they're secret. Should probably organize my notes a little better. What the frick? What did I do with it? Oh, here it is. And it's right. So there you go. But now, what we're going to do is solve horizontal, which is the last thing we're going to go over in this video. So the first thing you got to do for solving horizontal is you got to take these and then make them in terms of y. So basically, you're taking the stuff on the x and then moving it over to the y. So y equals negative x plus 4. Y equals negative x plus 4 minus 4 minus 4. Y minus 4 is equal to negative x. So x is equal to negative y plus 4. Yeah. Then y equals x. Now that's just going to be x equals y. We got y equals negative 3x plus 4. Here, I'm going to just circle these just so we know. Y minus 4 is equal to negative 3x divided by negative 3 divided by negative 3. So x is equal to y minus 4 over negative 3. Let me make sure you guys can see that. So these are our new 3 points. And what those points do is they basically take this graph right here and then turn it horizontal. So now this is what our graph kind of looks like. So instead of going from 0 to 2 like we were before, well, actually we're still going to 0 to 2, but we're counting it on the y-axis. Oh, I'm tripping. So we were going to 0 to 2 before, but now we are going from 4 to 1. If that makes sense. We're going from 4 to 1. I think that's... Or wait, is it like this? It might be like this. 1 to 4. I think it's like this. So now we're going from 1 to 4 instead of 0 to 2. And we're going to use these functions instead. So now let's plug it in. So if we look at it just like this, what? Yo, I'm tripping, man. Huh? I'm kind of confusing myself now. Alright, it's time to open up Desmos, make sure I'm doing this right. Oh man, I really don't want to stop this recording. So we're going 4 to 1. Alright, give me a second. Okay. So basically, what I got confused on is I was kind of looking at this from 4 to 1, which is right. But what we're doing is we're going from the lowest y to the biggest y, so from 1 to 4 still. All right? So yeah. Now that we got that out the way, let's do the stuff. So we got, looks like our top curve now is y equals x plus 4, and it's going up to here, then gets sliced off here, and it's there. Alright, so we should have from 1 to 4 of x plus 4. Oh, I mean negative y plus 4 now. dy. Then subtract from, looks like from 1 to 2. Yep, from 1 to 2. We're taking out y equals x, but it's in terms of y now, minus 1 to 2 y dy minus 2 to 4 of negative 3, or y minus 4 over 3 dy. Let me just confirm. So we have this from 1 to 2. We slice out this. And then from 2 to 4, it's slicing out that. I think. Wait, what? Brain's working. Alright, you know, I'm gonna check if this is right. We can enter it into the Desmos. So we got integral 1 to 4 you really do not want to edit this video, so that's why you're probably still here right now, even if anyone's watching. But these videos are really mostly for me anyway. Right, so looks like I messed up. So yeah, something definitely went wrong here. Let me just troubleshoot this for a minute because I'm so close to finishing this dang tutorial. You know what? I'm just look it up, bro. I've already gone so far. Gone this far. Might as well just keep recording. Alright, so it looks like I was doing it somewhat right. Okay. So this one's actually kind of confusing. This is really weird. I haven't seen this one before. I probably should have used a different one for this example. But this is actually like kind of like astounding. I didn't even know this before. So look. Let's put like this pencil here. Like if you do it like all like this, then you can't take the slices out. Otherwise it's going to give you like a weird value. But if you look at it like this, top curve, bottom curve, I mean, that makes sense. And then top curve, bottom curve, that also makes sense. So it's basically what it means is that it's as we go. So from here, we're subtracting out this portion. Then from here on, we're subtracting out this portion, I think. So yeah, I'm still a little confused. Let me check this out again. Oh, okay. Now it makes sense. So look, these two are different, but this is subtracted out both times. So from here it changes, and like from here it doesn't change. This is always the top curve, but look, when we have it here, this starts out as a top curve, then this becomes a top curve. So that's where it's getting confusing. We just learned something new for the test, and that's gonna help me out a lot. And I'm sorry, I kind of just did nothing there for a minute, but that's your brain thinking. It's my brain growing, brain becoming better. So let's scribble that out. Let's make a new one. So we got from 1 to 4. Well, actually, we're going to start this off. We're going to start with 1 to 2 because that is this top curve. So we got this, we got 1 to 2 of y dy minus 1 to 2 of y minus 4 over -3 plus 2 to 4 of -y plus 4 minus from 2 to 4 of y minus 4 put parentheses around just in case, and boom, that is officially our answer. If you plug that into the calculator, you should get 2. Thank you guys so much for watching. I need to go check my March Madness bracket, but we learned something new. I'm sorry for just blanking out there for a second. Hopefully you just skipped through that and you didn't have to watch me think. But my brain got bigger, and hopefully yours did too. And yeah, thank you. Bye.